more at the technology itself instead of looking at other things that are not really relatable to the fundamentals. But anyway, yeah, so let me just introduce myself. I'm Shreja. So I graduated from London School of Economics about 3 months ago, and I'm now working in the Central Bank of Malaysia, in Negara Malaysia, as an associate analyst. And basically, I like to explore things that are related to data analytics, and also in investment and finance. I also look at algorithmic trading, and some of my job scope is also relevant to, also requires me to follow the development of fintech in the country or in Southeast Asia mainly. So if you have any of my interests here, feel free to talk to me about these things. Yeah, so next thing, today's session flow, like I said, major parts will be on the introduction to blockchain, and then I'll try to give you as many live demo or the analogies to help you understand better, because there are a lot of intricacies in the whole development, and you have to understand that this thing is not very, in a sense, still not very easy for people to understand, because a lot of developers don't really focus on the marketing aspect unless they become very big and have the capacity to hire campaign manager, social media manager to help you understand more. So there's actually quite little resources. I'll try my best to let you understand the tech, and also we'll talk a bit about the types of cryptocurrencies. And the third part will mainly be on how do you actually buy bitcoins, for example, in Malaysia. Yep, and then we'll move on to Q&A. So so to begin with today's topic, I'd like to describe what blockchain is with a question. So think about it today. If you want to transfer 1,000 ringgit to your friends who uses another bank, so let's say you're using CIMB and your friends are using Maybank, and so when you use your mobile application to send your money over to him, does he get the money immediately or not? And the answer is actually no, in the sense that you actually have to make a request to your bank, which is CIMB, right, to adjust your account balance by 1,000 ringgit lower, and then you're essentially sending the request to the counterparty, which is the Maybank over here, before Maybank also make a move also adjust his accounting balance to add another 1,000 ringgit. And in short, what you should take away is that, okay, so there are actually a lot of third parties behind the scenes trying to facilitate the transactions, because they need to know whether it is really me sending the money over to the other person, and that there's no fraud involved and blah, 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 stuff like that. And yes, there are a lot of alternatives out there. For example, your traditional banks. Let's look at this, the middle column, like Visa and MasterCard, the acquiring banks, and also more newer alternatives in the US, in the Europe, like PayPal and Venmo are also catching up. And if you want to do remittances, Western Union. And these things usually incur quite a lot of costs, right? And you have to realize that some of the verification can be actually automated. It's just that the process is slow because the banks are big, and changes are always very difficult because companies have legacy systems in place that basically will make it so that you and your friends are also giving away some commission fee in a sense. And so we have established that the third party has the power to modify, delete, and keep these records, right? And these ledgers are basically private ledgers. So for example, CIMB keeps a list of all their customer accounting balance A, B, C, D, E, F, G. and Maybank also has some A, B, C, D, F, G, blah, blah, blah. And the essence is that they can actually single-handedly modify their records unless unless there's a, for example, a regulator that came in and say, okay, you actually credited maybe Treasure like another 1,000 ringgit more, and it just never showed up for a while until the regulator came in and checked it. And the issue stems from the fact that CIMB keeps their books closed, right? And because they are private, they are centralized and operated by CIMB itself. So even though CIMB is like the central node here, they deal with everyone on this link, but they actually, but for the users here to communicate with, let's say the Maybank users, they have to go through the central node, basically like talk to this bank and then jump to here. So for Maybank to process their request. And that's how the interbank transactions happen. So in simple terms, the two payment systems, they don't talk to each other. And there's like a missing link between the two. And when you try to bridge this link, there's often a lot of cost in it. And so you want to say, right, actually it's not that bad a thing. But then actually there is always a third-party risk whenever you use PayPal and local banks for transactions, precisely because they are private, they are centralized, and they are modifiable. These are all problematic features that theoretically will become a problem. So how is the blockchain different? Yeah, blockchain is, in the most general sense, publicly distributed, decentralized, and permanent records of statements. And the statements can actually be financial transactions, or maybe just like file transfers. But the essential idea is that blockchain, if you compare the left-hand side and the right-hand side of this thing, so first of all, the blockchain is, as you can see, there are a lot more nodes that are connecting with each other. And in analogous term, everyone can actually validate another person's transactions. So you no longer rely on, say, CIMB and Maybank to do the validation. And CIMB and Maybank, they can choose to delay your payment and whatever, right? But then and sometimes they do it with their own strange set of rules. But then in the blockchain system, usually, if you are willing to pay, let's say, the highest fee, the highest reward, then your payments get processed immediately. They'll get picked up by the different nodes that will validate your transaction. Sorry. Someone. Hi, Gilbert. Do you mind muting your speaker? Yeah. Right. So anyway, oops, I think I just refreshed the page. Okay, never mind. So just now I was trying to contrast the the private closed payment system with a blockchain, right? So this is just the manifestation of how.
Hi, Treasure.
Oh, hello. Yeah. Hi, Gilbert. Sorry. Actually, having some problems with the slides, but yep. So right, blockchain distributed in the sense that the public record is actually pretty much viewable by every user, and it's not. So what I'm saying is that it's not just, let's say, CIMB that has the bird eye view of all the transactions that has occurred over the network. Actually, you as a user can look at whatever transactions that has been done on this network, and that's a very powerful feature, right? Because this makes things transparent yet secure in a way, because for reasons that you see, that when everyone has the ability to look at every single transaction, it's actually very hard for a person to cheat the whole system by smuggling a fraudulent transaction into it. Okay, so that's distributed sense of it. And the decentralized sense is actually meaning that they will, is actually meaning that the, yeah, it's not just CIMB that can validate the transactions. And so the permanent one is that once so a blockchain can be imagined as a pile of records. And whenever you add, like I said, a statement, so financial transactions or any sort of data on it, it will be permanently accepted and stored in every validator's or user's, let's say, their computer. So you cannot go back and change one of the records, because that will mean that this pile of statements will become inconsistent. And so no one is going to use the inconsistent records. And actually, because of the force of I should say maybe the consistency of the users, they'll actually all flock towards going with the most, with the pure version of the blockchain. Yeah. So so we have established that the blockchain is different on these three bases. And then maybe just here, I'll just check what has happened on the other side. Yeah, ask any questions. Okay, cool. So yeah, in the most general sense, I just want to say that blockchain is just a technology for you to store data, and these features are not like a must for every blockchain. Some of them can be more decentralized than the others. These are just like different dimensions of the traits, and users sometimes will prefer different kinds of customizations, right, for their technology, for their services. So that's why you are seeing so many different cryptocurrencies. And cryptocurrencies are basically what's being moved around the blockchain in a sense. So yeah. So anyway, how transactions happen on the blockchain. Let me just check it. Yeah. So say, going back to the second slide, Alice tries to pay Bob 1,000 ringgit, let's say tonight at 9 a.m. Sorry, 9 p.m. So you are going to do this using your Bitcoin wallet, which is actually a software, a software, and then to ask the wallet to encrypt the details of the transaction. So obviously the transactions include something like the sender, Alice, recipient, the Bob, and then the date and the time. The amount in this case, I just assume that everyone's using Malaysian ringgit as reference, and some kind of a digital signature. This is like a private key that is only, maybe digital signature is not that accurate, but private key for us to know that it is actually Alice who who is trying to carry out this payment. And then the wallet will broadcast the transaction onto the whole network. So for the lack of a better graphic, let's just say, so one of the users here is trying to transmit, to try to pay this guy. So she's like sending a signal to everyone saying that, hey, I've just done a payment, can you just like verify it, so that he would know that I've sent the money to him, something like that. So when you send out so when you send out the encrypted data, right? Obviously you need it, because no one needs to know that you have actually given Bob 1,000 ringgit, right? That's like a security breach. So they will actually turn out to become a string of gibberish, a 64 character hash, when it is going on to the network. So they are going to transmit the transaction data onto the entire network. And the theory behind is that, okay, so when you send the message to the network, you try to encrypt it so that nobody really knows what's underneath the data. We only know that a transaction has happened, but we know nothing about when it happened, how much is involved, and things like that. So you can play with the encryption algorithm here, and you see that, okay, let's say I'm trying to paste this thing. So you realize that the hash that they generate is always consistent. So for example, first four digits is 1CF0. If I input the exact same data, it's going to give me the same hash. So it's like, this is like a key generator, and it's always consistent, but extremely hard to like reverse engineer. Because why do I say it's very hard to reverse engineer? Because, for example, even if I just add a space behind this whole thing, it will, the entire hash will change a completely different key. So you can imagine, let's say this is Henry and things like that. So it is a very quick way, I mean, this is just a very secure algorithms that are actually governing a lot of internet security. I heard that I just read that website sometimes uses security certificates that have this sort of encrypting mechanism behind, because we can't just let anyone to hack into the website, and yeah, the backend is sort of like protected with this sort of hashing algorithm. And so changing even the letter of the transaction detail will shift the output hash completely. And the next thing is that, okay, so the network has already received some gibberish, right? We don't actually know whether this is actually a legit transaction. And you can imagine, maybe there are like some fraudulent people who tries to send in multiple requests that are actually blank checks to the system, and in the hopes that this will get accepted into the legit blockchain to be received as the legitimate transactions. So how do miners understand whether this is actually actually transmitted, through a legit wallet and stuff like that? So to decrypt the transactions, now enter the concept of miners. Miners are basically people with computers, like really powerful computers, who try to reverse engineer. So when they look at the, the hash that's being generated, let's say they saw the 64 digits. So they need to, so they have no idea that this is Alice, right? Alice sending the Bob at this time. So basically they have to try a lot of inputs, maybe with a template. Maybe they keep on trying, okay, Henry, Jen, and then only they move on to Alice. And only they can find, okay, so this is the correct hash. This means that the input must have been Alice sending it to Bob. So they'll tell the entire network that, hey, can you come and look at this? This is probably, so when I say, hey, come and look at this, I'm actually telling the other people with computers who can validate that this is a legit transaction. And so yeah, you play with you look at the output, and then you play with your input generator sort of things to try to guess out which one is the correct input. And then after you have done that, tell everyone on your network as well. So like maybe this guy is the one with powerful computer. So once he cracked it, then he tells this person, hey, can you check if what I have is consistent with yours? So if a lot of people have confirmed that, a lot of people on the network have confirmed that, okay, it's consistent that Alice has sent 1,000 ringgit to Bob, then let's add it to our blockchain, which is the pile of papers that have a lot of data encrypted already. Then we add another line saying with the encrypted data, sorry, the decrypted one. So then it will be added permanently to the network, and you realize that these miners, they're actually really the grease that moves the whole system. Because without people who come in and validate the transactions, there'll be no transactions, right? There's no way to even know which one is real and not, and what not. People will lose trust and stuff like that. And the advantage of having this sort of validation system is that is that it's pretty difficult to hack the blockchain. So for example, how, can I just announce to, maybe if I control enough computers here, right? Let's say there's 2, 4, 6, 8, 10 computers. So maybe I can control 5 of them, and then I expose some fake details, fake transactions, and say, hey, actually, I've paid this friend 1 million, and then like 6 computers agree because I control all of them. So like, okay, well, these 4 also cannot say anything because the majority has agreed that this is a legit one. So we are gonna add on to the fraudulent. Sorry, we're gonna add on the fraudulent transactions to the list of blocks, right? Um, yeah, but then this thing doesn't happen in real life because we are not just looking at 10 computers, but the fact that there are, actually I don't know what the amount of mining machines in the world, but I'm pretty sure that no one has the ability to say control half of the half of the entire world's most powerful computers so that he can get the agreement of the majority of the network at any instant. And need to do it every single time because every time in the future you continue with your fraudulent network and somebody discovers that, okay, you are not being consistent at all. So let's go back to the root of it, to the initial state, and not not authorize you any of the money that you have in that you have made after the fraudulent event happened. And that's actually a real thing on blockchain, and that's why hacking a blockchain is always very risky because and comes with very little payoff in a sense. Yeah, simply because there are a lot of safeguards in the process. So yep, the decentralized nature makes it very hard for anyone to even attempt hacking. In this case, right, if it's CIMB doing all the authorizations for our interbank payment, yeah, if I can actually hack into say CIMB's mainframe and change everything overnight, actually there's very little things CIMB can do except to kick me out of the system and stuff like that. So when you are using a centralized payment system, you are really relying on that one authority doing their job well. But then in here, the entire computing force of the world are actually coming in to sort of like secure the the legitimacy of the transactions here. And that's why you have actually just look at the entire process of how transactions occur. So after all this demo, actually it's a pretty long description, and then I can actually show you how the blockchain histories come about. Maybe I'll just show this first. So for example, if I go to a Bitcoin blockchain website, it's going to change the language to English. And then, oops, didn't change. What happening? Let me see. Bessie is shaking her head. Okay, yeah, I think I have the English ones. So anyway, yeah. So looking at the blocks mine, yeah, I think I've missed pretty important like visualizations of how blockchains can be imagined because I say they are actually like a pie of letters, right? So just think of blockchain as a lot of envelopes that has data stored in it, and they're just like piling up in a certain structure. They're certainly not like this in a very messy way, but way more structured. Maybe it's even like linear, like a tower building up. And whenever new envelopes get thrown in, you can call them like a block, like a block that is containing all the data. So for example, let's look at uh, Bitcoin's blocks. So you realize a few things. This is the height of the block. So this is block number 486782. What this means is that in the whole history of Bitcoin, there has been around 500,000 blocks being created. And then you can see that one block is about, it's actually hard to say what's the size of every block, but it's around 1 MB in this case. But you notice that the maximum size of a block never exceeds, let's say, 1.2 MB. There's actually a limit. This is actually a limit design when Bitcoin was conceived. And if you look at the time, in this hour there has been just 2 blocks mined out, all right, in 36 and 19 minutes. In the last hour there were around 6. Yep, there's around 6. And you can just like do your maths about how much transactions have gone through. So the relay by basically is the miner's names up. And in today, a lot of mining powers are actually being is not no longer super centralized, but it is actually being like aggregated in a lot of groups, and they don't necessarily have to be from the same country, same continent even. They can sort of like you can actually like lend your computing power to a cloud mining group, and when one block gets mined out, the entire users of that group gets proportionate reward based on how much computing power they have contributed into cracking the transactions, like I said earlier, the transactions encryption. So that's the part for that. I can explain to you the height, the time, the relay, the size. Okay, now let's go to the hash. So the hash is basically the encryption, right? And you notice, I don't know how many letters are there, but I think this is a 64-byte hash. And what this means is that, 64 bytes. It's just the same as what this thing will create. So yeah, basically the miners they look at this and then they sort of have to guess what happened here, to get to this hash. Yeah. So you notice that Bitcoin hash always has about 14 zeros preceding them. That's just a minor feature of how the hashing algorithm happens. So now let's go into one of the block and see what's going on here. You all can do the same thing as well, just to play around. Yeah, so basically, this is actually telling you that, showing Spanish again. Right, can fix it. Right, so that I think it's telling us that there's about 1,500 transactions in a single block, and then the block reward. So the reward for getting out this block, is 12.5 Bitcoins, and that's quite a lot. I think that's about, let's say, 47,000 USD just for mining out this block. But obviously, you're sharing with a lot of people the reward, and there are actually transaction fees that the users pay you as well. But I don't think it's super significant. According to here, it's only about 1.3 Bitcoins. But apparently in the future, block rewards will be reduced, and commission from transactions will actually play a big role in motivating the miners to come back and validate our transactions. So anyway, these are actually the transactions that has occurred. If I'm not mistaken, this is an individual transaction ID. So this is the hash is like the identity of the block. But then these are actually the identity of a transaction. Queries are basically one address sending to 2 different addresses, like one money going to 2 places. It looks a bit strange. Maybe there. Yeah. Yeah. So let me just clarify. So in this case, right, 0.42. So this guy was trying to send to here, like 1HZ sent to 1BL, and then 0.005 Bitcoin is actually the reward for the transaction fee for the miner. So these people who receive like 0.0 something Bitcoins, they're actually all miner addresses who are getting the reward. And then these are actually the users these are the actual users who are involved in the transaction. These guys are just third parties, and you realize that they're never the same, right? Okay, maybe I think in this case, this guy and these guys are the same, but overall you shouldn't be seeing at too many validators from the same source up, right? Not because we said that Bitcoin is decentralized. In the alternative scenario, right? If you are actually looking at the let's say CIMB's internet payment system, all the miners, is gonna be CIMB, 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 right? So that's what's going on. Like it's decentralized and everything is permanent on this blockchain. For nobody is gonna be able to change it forever, stuff like that. So that's why blockchain is cool. Yep. So let me see. Um, yep. Example of blockchain history. That's it. Yeah. So I'll just open this question to like pick your brains a bit. So typically the data size of a Bitcoin transaction is 250 bytes, about 250 characters. And the blockchain is designed to produce 1 MB of empty blocks every 10 minutes for us to add transactions data on it. So there is actually discussion on why this should stay at 1 MB and not higher. And actually we'll be discussing why is it such a controversial issue. So actually the question is how many transactions do you think a 1 MB block can store? Just gonna monitor to see anyone is answering this question. Any takers?
4 million?
Nope. It's actually 4,000. Yeah, right. So yeah, 4,000. So okay, so 4,000 transactions in 1 MB block. And then every 10 minutes, one MB block. So this means that 600 seconds for one MB block. I'm just trying to like let you get a sense of how fast the Bitcoin process action. It's actually 4,000 blah 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 blah. 4,000 transactions over 600 seconds, which is about 7. Yep, it's about 7 transactions per second. And that is actually not very fast. It means that Bitcoin at its current capacity, current capacities can only handle 7 transactions in the entire world at any second. And that's actually a big technological limitation as of now, because if you look at PayPal, I think I actually have some data on it. If you look at PayPal, PayPal can actually do transactions at the rate of 500. At a rate of 500 transactions per second. And Alipay, so Alipay can actually do about I heard, I'm not very sure, have some source that says that they can do 50,000 transactions for a second when it's during like the peak November 11 sales. And that's how crazy payment system can get. Yeah, that's it for now. Let you have a sense of how well Bitcoin will scale, whether and then you can make a judgment on whether a payment system that can handle 7 transactions a second can actually be a global currency. But yeah, that's for anyone's opinion. So yeah, blockchain summary, just in simple terms, decentralized nature, everyone can become validated as long as you have a good enough GPU units and stuff like that. So there are actually even Malaysians doing Ethereum mining, as far as I know. Yeah, things like that, and there's no central authority overlooking all these transactions, right? Okay, I mean you can say that the government might want to shut down miners and stuff like that, but in the nature of the design, no one can actually, not even the developers can come in and then like shut down anyone's rights to stay on the network and stuff like that. There are other mechanisms in other coins to like sort of balance out the dynamics. Sometimes like sometimes they give like voting power to the coin holders to decide the future of the coin or what should we develop, stuff like that. That's also actually one of the. So Dashcoin has some kind of a voting community that decides on the development direction for the developing teams. And that's actually quite a good feature because that means that whatever features that you're adding is also desirable to your users, right? And the way you do it is pretty much like whenever you send a transaction, say there was a proposal to
Hi, Patrick.
Hi, Patrick. Yeah, so say there was a proposal to add a feature yesterday, then you can add one to the transaction to agree to indicate agreement or zero otherwise. It's a pretty cute feature. Like you just have to tell them yes or no by adding one to your like transaction details there. Yeah, that's just the very like watered down watered down idea of how you actually vote using coins. So next thing is that distributed ledger. I'm not sure whether just saying that any user can view the public ledger online is a good enough definition of its distributedness. If I'm just assuming that this separates them from a private ledger where no one other than say the bank holds the entire repository, the entire copies of the history of whatever that's happening. And so permanent meaning in most blockchain platforms, if you want to if you want to become a miner, you actually have to download the entire history, the entire 480 blocks of data onto a computer before you can run your mining process, because that's to sort of like ensure your blockchain consistencies in a way. But there are also people saying that, oh, what happens if 10 years later we have like 10 million blocks and then suddenly every block is about 1 MB, then how big of a hard drive are you gonna like be servicing, be buying? That's one of the technological issues, but not a very critical one, at least at least as of the say next 2 or 3 years. Yep. So yeah, cryptocurrencies today, this is just a very convenient websites for anyone to like check out the current market capitalization. So to give you an overview, you can actually not look at all the individual coins first, but come to here and look at the global charts. This is the development. So In the past, it has been hovering around 1 billion market cap for many, many, many years. Okay, I mean below 10 billion, let's say. So I don't know, maybe like since a little over 15, 16 months ago, then they started going into like a hyper growth period. And the peak was about this month's beginning, but then it has since fallen back to around 130 billion USD in market cap. And you can see that Bitcoin alone is capturing about 50% of the market cap of this entire like space, as we call it. Ethereum is a very distant, it's a pretty distant second, but the other coins are also very, very significantly behind. And I can maybe just do a short intro to the coins that I'm a bit familiar with. So Bitcoin obviously the most famous ones. The sole usage is for transactions only, and I say that because Ethereum is actually a platform where you can like build apps on it. Like you can actually like write code on top of the Ethereum platform, and they call it like a Ethereum apps. So I don't actually know.
Is it a
Smart
smart contract?
Yeah, I mean, yes, you can write smart contracts on it. So, but the apps seems to be even more diverse than all of these things. So I'm just not very sure. Like these are actually the little applications that you can do, like whatever money setting, like policy initiative. I think, yeah, audit platform for smart contract. These are all like, yeah, what people have been doing with the Ethereum platform. Like you can't do these things on say Bitcoin or uh, there are actually very little. The more valuable coins now are actually like platform coins like Ethereum, NEM, or like Ripple itself is still a currency, or like Saver and also Waves. They're all platform coins that have their own extensions. Yeah, things like that. So anyway, this is one example. So Ethereum itself, it's had a crazy run. So about a year ago, its price was actually around in USD terms 20 times lesser than its current state. So that was pretty crazy. Going from about 1 billion market cap to today is 27 billion. But that's also partly because there has been some issues with Bitcoin future development. So people are actually looking for alternatives. Yeah. So these are the two. And Bitcoin Cash is the product of a hard fork. Yeah, I think we call it hard fork. That happened about 2 months ago with Bitcoin. So basically, a hard fork happens when, yeah, I'm just gonna write it out. So a hard fork happens when somebody is, I mean, the developing teams are not agreeing to what software renewal, software difference, software divergence due to difference in opinions of the so like they couldn't agree whether say okay, so Bitcoin just now we say like okay, how come like 1 minute 10 minutes can only do like 1 MB, so little. So like some other people say, hey, why don't we move it to 8 MB so that suddenly we can fit in 8 times the size, then maybe our transactions per second also can go from 7 to 56 per second. Isn't that very good? But the Bitcoin traditionalists don't really agree with that, so they say to hell with it. And in the end, they couldn't come to agreement on one unified direction. And then like some of the developers went on to develop Bitcoin Cash, and they have this 8 MB blocks, but then the Bitcoin is still staying with like 1 MB blocks. But they're trying to solve these things with like other technologies. I mean, so the difference was basically drilling down to whether Bitcoin thinks that the scaling issue is so serious that we need to change one of the fundamental design, that is the block size of the blockchain block. I mean, this doesn't really fundamentally change the previous blocks. You can just imagine like, okay, like this single envelope is like 2 thin, right? So maybe this is like 1 MB. But some people want to say, hey, why don't I put a 8 MB envelope on it? Isn't it pretty good? So every 10 minutes I'm processing more letters. It doesn't really affect the underlying blockchains. So actually Bitcoin Cash, I think they are continuing on the blocks that at the same time, sorry, the blocks that have maintained until the time where they are the split happened. Yeah, hope that's not very confusing. But then, so Ripple itself is also a very interesting case. I think they have already been collaborating with some Asian central banks in trying to develop an actual like blockchain technology that can run and integrate overseas banks and whatever. So yeah, these coins are all pretty active on the social media. Like they actually had some conferences in the past and a lot of discussion with the authority. And these are actually the coins that people will sort of like support because they have already been taken up by the central banks and whatnot. So there's actually more credibility to development. And Dash is trying to become, I think they call themselves is the silver to Bitcoin. So like, so yeah, it's either Litecoin. Sorry, maybe it's what they call Litecoin. Yeah. So Litecoin is Dash and Litecoins are basically also just currencies, but Dash has some pretty interesting features like I mentioned. They can actually do like the voting mechanisms, and the rewards for the miners and the developers are a bit different from what the Bitcoin teams are going about. So what I'm saying is that the Bitcoin teams, right? Developers get I think zero money out of like developing this whole thing. So Bitcoin developers are there basically only because they have a stake in it. They really are passionate about it. But what I'm saying is that Dash has actually like sort of a payout of salaries to their developing teams. About I think 10% goes to Dash developers, and only like 45% the 45% of the the coins or whatever rewards goes to the miners and stuff like that. And as long as you own about 1,000 Dash coins, you have you are like their shareholder lah, so you can vote in their development projects. Yeah. So Litecoin is like a spin-off from Bitcoin. They have a lot of new features that make them really convenient to make payments with. Yeah, and that's it. NEM is a very interesting case. They actually try to talk to Malaysia's Digital Economy Corporation to sort of like launch some partnership. And just this month, I think they are trying to set up some kind of digital center in Kota Damansara. I don't exactly know what they're doing. The website is very fancy, and there has been a lot of chatter about collaborating with Malaysia. So yeah, the blockchain center here. So it sounds pretty legit. Yep. IOTA, I'm not very sure. It has something to do with Internet of Things. Monero is a invisible coin in the sense that they are trying to really install a lot of like privacy measures for their users, and this makes it very easy to sorry very appealing to the users who prefer like really anonymity in their money transfer. Yep, I think that's all for this. These are also pretty interesting coins. There's just a lot, and researching all of them will take a lot of time. And so yeah, take a short break. Right, so in terms of how do you buy Bitcoins, the only thing I've seen, let's say on the internet, sorry, I mean the Malaysian forums, I think Luno is the most secure one. It comes in the form of a mobile app as well, so you can like check out the features. It is basically an exchange, and you can deposit pretty easily with 7 clicks or Maybank to you. And there's a slight premium on your Bitcoin prices. I think you can only buy Bitcoin on this platform, not any, not any of the other coins that I just show you. And then, and yeah, and it's slightly more expensive lah. And I say slight premium compared to if you buy overseas. And there's a tiered KYC, which means that the verification process is sort of like if you don't send in your passport and stuff like that for verification, I think you can only trade 5,000 ringgit. So yeah, there's also CoinHeckle. I think it operated in Singapore in the past, and they are trying to resume operations in Malaysia. But yeah, that's about it for online trading. If you want to do like peer-to-peer exchange, you can go local Bitcoins. Like it's a pretty ancient way of like dealing in Bitcoins. Essentially, what you have to do is obviously to change your fiat currency, which is Malaysian ringgit, to Bitcoins before you can like buy other alternative coins on other exchanges. So this is just the first step. Like this is buying Bitcoins, but not buying alternative coins like Dash and Litecoin or whatever. So yeah, it's not really that developed. In Malaysia, it's not a lot of choices, and that's why you are seeing a slight premium here. Yes, so I think that's it. I think you guys can start adding your questions to the channel. Yeah, I'll be looking, yeah, I'll be looking over there. A bit. What is that? Bitcoin. Uh, okay, yeah, cool. And then I have two questions prepared here. So it's the technical limitations of cryptocurrencies. One is the scaling problem, and I think it's a pretty serious problem. So like this question was asked by Carl Jun initially. Not sure if it's here, but anyway. So scaling problem, like I said, that the transaction speed is a bit too slow for it to even be scaled to a global usage kind of stuff. So there are a lot of ways you can go about it because we said that data size of a Bitcoin transaction is typically 250 bytes. So it contains the transaction details, digital signatures, blah blah blah. And now we are actually and if you keep this unchanged, right, Bitcoin will probably stay like that. And that's actually a problem. So there are new solutions being um, being proposed. This is slightly more advanced, so this is called a segregated witness. And you'll notice that on Wiki they call it a soft fork because a soft fork apparently doesn't require a new software change or something like that if you are like the miner or the wallet user. So, so essentially they are saying that okay, why like I understand that the TX details are transaction details are important, but maybe you can shorten the digital signatures. Maybe it can be like taken out and stored somewhere instead of the main pile of letters, right? So and then this takes about 1/3 of the 250 bytes. What it means is that if the developing teams come to terms about okay, cutting out the digital signatures to something trim, something shorter, then maybe you can fit in 1/3 more transactions into it. Yeah, that's just one idea. And there's also something called a Lightning Network, very fancy names, so segregated. witness. And then there's this thing called Lightning Network that actually wants to, help the Bitcoin users solve a very critical problem, which is that when they want to pay for coffee, takkan I want to wait for like 3-4 minutes for, sorry, I mean like 15 minutes for the transactions to be confirmed before I can leave the coffee shop, right? So they are trying to come up with an offline, they're trying to come up with an offline channel for the transaction to happen. And when that happens, that okay, so it's something like the coffee shop can try to keep the channel open, and then let multiple users join in, and then they sort of like package the data, and then try to settle it among this small user group first before uploading the, 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 the transactions onto the blockchain. But then what's the incentive to prevent them to cheat is that I think you need to have some small deposit on the network so that when you cheat, right, then the coffee shop will sort of like they can take away the deposit if you like fail a payment or whatever. So there's actually no incentive for you to cheat over like a small cup of coffee to lose maybe like 50 ringgit, lose 50 USD, stuff like that. But then implementation is still an issue. Is an ongoing development, but you can check out more how the updates are. Not very close to it. And secondly, I think user friendliness is a huge issue. Yeah, so how do you deal with accidental sends? Like these things, right? If you say that this is permanent, then it's forever being stored in the block. How am I gonna like retrieve a wrong payment? Let's say I type 1,000 instead of 100 USD cent. There's no customer support that's gonna talk to me and try to refund me the money. That's a huge issue. Yeah, and some of the coins, I think Dash is trying to fix that. Yep. So, and also it actually uses a lot of electricity. Apparently, it will to mine one single Bitcoin actually can power a whole the electricity usage of a US household for a year. I'm not sure whether that's like accurate, but then sounds accurate to me. And that's actually a crazy amount of electricity. And in some cases, if you're not like maintaining your mining mining workplace very well, accidents can happen and stuff like that. Countries are actually trying to leverage on their relatively cold climate, like some Scandinavian countries or the, the Russians, they are like building mining farms, like at really, really cold place so that they can run their mining farms more efficiently at a lower cost. And then I think Andrew also talked about cryptocurrencies as a hedging tool or growth instrument. So actually cryptocurrencies, the value is really if we are talking about like bitcoins and not Ethereum and stuff, the only value is as a currency, right? And your value comes from providing utility and whatnot. But for now, it's too volatile to become a currency, like a legit currency. So that's not happening anytime soon. But it is a good hedge to the international conflict. So for example, like who knows if North Korea wants to bomb the US next week. And I think when that happens, cryptocurrency market cap will probably not go down but go up because it can be a safe haven from the fiat currencies. And then secondly, in terms of international conflicts, there are actually like news that these sort of cryptocurrencies are being used to, yeah, in Venezuela or like countries troubled by corruptions and hyperinflation. And this is actually because they are actually more stable and more useful than their own national currency. But in the end, yeah, it's a hedge to a lot of conflicts and stuff. But then as a growth instrument, there's actually a lot of headwinds at the moment with big countries like China trying to ban the exchange of cryptocurrencies in the country. And whenever regulatory risk comes in, no matter how good a trader or analyst you are, you usually lose out money when the whole market is going down. And that's what happened. And that's what happened in the last month. The whole market was down in terms of market cap, total market cap about 30-40%. And if you can't stomach that, then cryptocurrency is really not so much of a viable investments. And yeah, that's just, I think that's all. So do you guys have any comments? Oh yeah, Dunha asked a question. So the hard fork. Yep, so the hard forks basically, like I mentioned, the difference in opinion between the teams. And then, and yeah, I mean the Bitcoin Cash is basically representing the miners camp, because the miners, they actually have they don't mind having more transactions coming in, right? Because they want to process more payments. But if let's say they want to stick with Bitcoin, which is to stick with the 1 MB block size, and to go with solutions such as segregated witness and also Lightning Network. These things will actually reduce the need for a miner to validate the transactions, because you notice how Lightning Network packages the transactions before uploading them. And segregated witness, not so, but it's a preparation to implementing Lightning Network. And when that is happening, obviously the miners are not going to sit and die and let the Bitcoin developers cut them out of the rewards, the block rewards. So that's why they sort of like initiated the hard fork. It was a very messy time. Uh, yeah, it was a very messy time, and then it turned out that Bitcoin Cash actually survived until today. But yeah, pretty skeptical on both camps, because they all have very ancient like developing mindsets, and there's actually a lot of like infighting within their own developing teams, and that's not very good for the futures of both coins. So yeah, let's say what to mention. Terrorist organization financing. Yeah, that's true as well. I'm not sure whether you mean it as a criticism to cryptocurrency, but mm, yeah, in terms of how Bitcoin is currently run, because of you know in any currencies there are like security and also convenience kind of, oh sorry, security and also cost kind of comparison. And Bitcoin is actually a pretty secure coin at the expense of high transaction fees. And then, but it also means that it is secure enough, for terrorists to use it, because it's not that traceable. And but then yeah, there are actually other mainstream coins that try to fix that problem. So like maybe in terms of, like I said, the spectrum of anonymity, there are another product that is making the public data available upon, let's say, regulators' request. Then actually that will be viewed very, very favorably by the regulator, right? Maybe not so for us, but for them it's a damn good idea, because I have the blockchain benefits, but then I have no worries about people like abusing the payment channel. So in that case, yeah, which is why I say the blockchain technology itself is very exciting, very, very good. It can be used in a lot of applications like law, even in the law industry, and not just finance. So, but then what cryptocurrencies come out of it is very, very diverse, and you can't like just say, okay, because Bitcoin is used by terrorists, and that means that it's a very sinful coin, it's bad. Yeah, that's just about 2 cents. And then, yeah, so but I think Malaysia banks will implement blockchain anytime soon. I'm not speaking on behalf of a central bank, but then I think we are coming out, yeah, we're coming out with guidelines as per the governor's statement last week, coming out with guidelines for cryptocurrencies by year end. No one knows whether this is going to be a positive one or not. And so implement blockchain. Implementing, I don't think will be anytime soon. Maybe the banks will join some sort of consortium to like uh, reap the benefits of blockchain, but I don't think anyone is like looking to implement their own. Sorry, like develop their own. Yeah, but that's just the current state of the, the financial institutions, all pulling together to develop one single blockchain. And that actually makes the use of these cryptocurrencies a bit skeptical, right? Suspicious, because who knows if who knows if like the private sector will develop a solution and all these coins will just die, and they're just like stepping stones to the eventual mature technology accepted by all big institutions and all. Yeah. Any other questions? Given that oh yeah. So Gilbert's question. Given that it takes increasing power to generate. Actually, I'm not sure about the answer to this question. The problem with Bitcoins being harder to mine is a problem in the sense that you will need like higher transaction fees to like entice them to service us, which is why like the servicing fees has been going up quite a lot. Let's see the commission. The cost of money. Yeah, total transaction fees okay, yeah, were like really rising a lot until I don't know what happened. Maybe it's because of the hard fork, or like people are just not using Bitcoin for transactions. So, but then it has been an issue as more and more Bitcoins are being given as transaction fees, and which is why I say the Bitcoin is really going towards the direction where okay, you are more secure. That's why you probably need to pay high fee. If you are just like a casual user, then probably you just go for Dash or Litecoin for your coffee purchase. So yeah, so in that sense, the difficulty is a problem. But I think difficulty increment is a common issue for a lot of other coins also. And I guess we just have to see how the Bitcoin developer teams will solve it. Yeah. So, any more questions? Any response from the crowd? Okay, if that's all, I think we'll just stop the session here. Yeah, are you here? Yeah. So, see. Yep, yep. No problem.
Thank you, Shreya, for the session.
Okay.
See you, guys.
Yeah, see you guys.